Well, good morning, everyone. And thank you for getting up this early to attend this session. Hope you had a great evening yesterday. I'm going to talk about EF Core 8. But before I do that, I would like you all to present yourself by way of raising your hand. How many have been working with a version of Entity Framework before? You all have. Thank you. So we don't need to start with Adam and Eve. Nice to know. Well, my name is Erik Ejlskov Jensen, and in terms of Entity Framework Core, I contribute to the Entity Framework Core open source project, and also to the underlying driver for SQL Server called Microsoft Data SQL Client. I also create a number of tools and libraries that are published on GitHub to help developers be more productive with .NET data access, in particular against SQL Server and Azure SQL Database. So just a quick roundup. What is Entity Framework Core? Is a lightweight, extensible, open source and cross-platform version of Entity Framework data access technology for .NET. Lightweight, meaning that it's actually able to run on mobile phones and on the most powerful servers in the cloud. It's extensible, it's based on dependency injection, and all the components of the framework can be replaced with your own implementation. It's open source and developed by a team of developers on GitHub, both from Microsoft and from the community. And it's cross-platform because it's based on .NET Core, so it can run on Mac, Linux, and Windows, of course. And you can use it as an object relational mapper, which makes you very productive in terms of working with .NET, with databases, and it eliminates the need for you to write a lot of SQL, mundane SQL code that you would otherwise have to write or code generate. It does all that for you. EF Core supports a number of relational database engines, SQL Server, Azure SQL Database, Postgres, Oracle, MySQL, SQLite. It also supports a couple of NoSQL databases, notably Microsoft's Cosmos DB, and recently a MongoDB provider for EF Core has been published for EF Core 6 and 7. And EF Core, as I mentioned before, it's open source and maintained on GitHub by 5 Microsoft employees, and of course they accept contributions from the community, including myself. EF Core was originally launched together with .NET Core 1.0 in 2016 and has had 7 revisions since then. So it's kind of not a startup product anymore, it's kind of maturing. And a lot of the work that goes into it these days is making feature parity with the good features that are still missing from the predecessor called Entity Framework. As you may know, Entity Framework Core releases together with each .NET release. So it's kind of fixed for the team when they will be releasing. They will be releasing the exact same time as any new version of .NET releases. And .NET release schedule is so that each uneven numbered version releases and then is supported for about 2 years. And it's called, 18 months, 1.5 years, and it's called standard term support. And EF Core 8 is a long-term supported release, which will be patched and supported for 36 months, i.e. 3 years. So that also means if you are adopting .NET or your customers are using any version of .NET, they are obliged to update on a regular basis, because otherwise it will be running an unsupported version of .NET, and everything that it relies on. And no support for security fixes and so on will be released for that particular version if it's out of support. So EF Core, the EF Core lifecycle, just to be a little more specific, EF Core 8 will end in November 2026. So it will be released on next week, actually, during .NET Conf on November 14th. And if you're running EF Core 6, that will end in November 2024, so like a year from now. So you have, if you're running that long-term support version, you have a year to update, so to speak. And if you're using EF Core 7, which is the latest released version, support for that already ends in May 2024. So that's in like half a year. And after that time, no security fixes and so on, no patches will be released for that version. So if you have software in production that runs EF Core 7, I would recommend that you wait until sometime in spring. There's always bugs discovered in new versions, so wait for like the first patch release of EF Core 8 to adopt it, and then update your software. Also notable is that EF Core 8 actually requires you to run .NET 8. So EF Core 7 runs on .NET 6 and .NET 7, whereas EF Core 8 actually requires you to switch to .NET 8. I wouldn't consider it an issue, it's just something that you have to keep in mind. So if you have some dependencies, some third-party dependencies, potentially there could be breaking changes, making them break with the new version of .NET. And if you're running software that has older versions of EF Core, like 5 or 3 or 2 or 1, you are completely out of support, and you should definitely consider updating. One of the first features I'm going to mention here that I think are notable in EF Core 8 is support for primitive collection properties. And what do I mean when I say that? Sometimes you want to model something in your database table that's just a list of something, a simple type, a simple scalar type, like a number or a date, or could even be a GUID, even URI, because it's basically just a string. And you think, how do I model? You have to think about how do I model that inside my table. So there's multiple options. You can have it as a separate table. So you link with a foreign key, you link to a particular table that contains a list of those additional values. But this seems like a lot of overhead if it's just a list of integers or dates or whatever. Or you can write your own mechanism to serialize and deserialize this list to and from like a character field in your main table. But it doesn't really play well with Entity Framework Core because it doesn't understand what's actually going on under the covers. You're kind of shortcutting it. So what they have added in EF Core 8, in connection with another feature which we'll come to next, is the fact that they now support, built into the product, they now support that if you define a collection of primitive types, it will be serialized and deserialized as JSON payload inside your table in varchar column. You can discuss whether that's a good pattern or not, but it's definitely, I think it's actually quite a good solution because it saves you the overhead of having a table just with a one column value and then a foreign key to your main table. But let's see how it works in practice. So I'm going to show you here in this project, and I'm running this project here in the latest preview of Visual Studio. And I'm running .NET 8, as you can see, down here. And I have included the latest stable build, the latest stable daily build of EF Core 8 in my my NuGet packages. You have to pin to this latest stable build or wait for 8.0 because things are in motion at the moment, because they're getting ready for the release in basically just a week's time from now. Let's try to run this. So, sample. So, in this code, we have a list of primitive collections, and as part of booting up the database, let me just scroll here a bit. Can everybody see this? I can make it larger if you want. Maybe not a lot larger, but yeah, nobody's complaining. So we're actually adding some data to these primitive lists here as part of initializing the database. And that happens up here. Let's just see. That happens up here. This code here, ensure deleted async and ensure created async, is not some methods you ever want to put into production code. I'm just saying because it looks kind of easy and magic, and it certainly is, but it's not some code that you want to put into production code. Ensure deleted async will actually ensure that your database is deleted asynchronously, as it says, including dropping your database. And ensure created will just blindly create all the tables in your database. It's really nice to have these methods. I appreciate that the team did those for demo purposes, but it's never something you want to do in production. You want to use migrations or scaffolding for production database initialization. And it also they have this seed feature where you can actually, I think in this instance they're actually just adding some stuff, but they also have migrations seeding where you can actually add data to your to your database as part of running your migrations. I would also advise people not to use that feature because it's a dead end. If you want to add like seed data to your features to your database, use other means of doing that. So then they are enabling logging, and then they're clearing a change tracker so we can see exactly what's going on, because they have already done some additions to the database and we want everything to start fresh. I think this change tracker clear was also added quite recently as a new feature to clear the change tracker before you had to iterate all items in the change tracker and clear them individually. So let's try to run this, and I will just show you my SQL Server Object Explorer here. So I'm running this against my local DB, and I will just delete this database just to make sure I'm not cheating anyone here. So now the database will be dropped, but I just dropped it so it doesn't exist. It will be dropped quickly. It will be created and then it will be seeded. And let's just have a look at the seeded database. Let's refresh. So the database has now magically reappeared, and it even contains some tables. So let's view the data in here. I will try to zoom in a bit. And here you can see the JSON fragments that have been added to the database columns that represents the primitive collections. Basically just JSON representations of strings, dates, and numbers and GUIs. And let's try to go back to the code here. That's it. Now let's try to run some queries against this. There's also a primitive collection. Sorry, that works with terrain. Yeah. So let's go to this one. F10. So you can see here. We have this. So here you can see, let me just enlarge that a little bit. Here you can see the query that's actually executed. And you can see it's using OpenJSON, which is a JSON method that was added to SQL Server 2016. And almost all other database engines has a similar feature, which will take a JSON payload and basically convert that to a table object inside the database engine. So it will open the columns here and then compare that, or make that JSON string into something that looks like a table, and then you can join that table with other tables or do queries based on that table. So we will look at the tables, the list of terrain numbers here, for example. Let's go to the next query. So here. And here the parameters are just a single beer type. But basically the same technology is used to query the database, opening up the JSON and treating it as a table. And then you can do comparisons or in statements in this case with that table object inside the database. And we can do other queries. I will not go through those. As I mentioned, this is something that was introduced in SQL Server 2016. And it actually requires your SQL Server database to be on a particular compatibility level. So compatibility level and product version is two different things. There's a max compatibility level per product version, but you can easily run a lower compatibility level in a particular product version. So for example, if you have migrated a SQL Server 2008 database with some database technology from Microsoft to migrate databases to your cloud, it will actually stay, unless you do something actively, it will stay on compatibility level, I think it's 100, if you move it to Azure, for example. And what happens if your database is running in a lower compatibility level? Well, since 2014, SQL Server 2014 is still in support, for at least for a couple of years until now. The team actually had to make it an option to tell Entity Framework what compatibility level your database is running in. It will assume that you're running a newer compatibility level, i.e. post 2016, which is 130. But in case that, if that's not the case, you can tell Entity Framework that you're running a lower compatibility level as part of your options when you're when you're adding your DB context. They have added a new option called Use Compatibility Level, and we will try to set it to tell EF Core that we are running now a database in compatibility level 120. So EF Core doesn't look at the compatibility level of the database. It doesn't query the compatibility level of the database, because then it would have to do that, I don't know when, or how often it would have to do that. So it doesn't do that. But you are responsible for actually, you will get errors if your database is below compatibility level 130 and you run particular queries. So it's definitely a breaking change in EF Core 8 this. So let's try to run this again, and now we're telling EF Core that we're actually running as if we were a 2014, SQL Server 2014 engine. Again, we'll recreate the database. And seed it. And do a query. This query actually passed. Let's see what it looks like. It's a little bit different. As you can see, it has the numbers, the parameter values. They're not parameters anymore. They're just hard-coded inside the query. Does anybody know why that is a problem? No one? That is a problem. I don't know if it's particular for SQL Server, but that is a problem because SQL Server has a cache of all its queries. All those queries has a particular shape, and for each shape it has a cache entry. That shape is the text, the actual text of the query. So imagine you have a very busy site where each query comes in with a different set of these terrain numbers. You will end up filling the query cache on your database server with different values, because each query string represents a different value. And if you have a very relatively busy system, the server will do nothing but finding out which of those queries should be evicted next, and it will not be able to serve normal queries, because the query cache is a limited resource in the database engine. And once it's full, it has to start throwing away stuff. So people really wanted this to change. And the reason why we can do this with the OpenJSON queries and the primitive collections is because the team actually decided to fix this particular performance feature by using OpenJSON. So they're basically sending a table parameter to the database, but serialized as a JSON string, and then using OpenJSON in the database engine, avoiding the so-called cache pollution in the database engine. Let's try to run the next query. Oh, that failed. Getting some error here. The link expression contains could not be translated. Actually, contains cannot be easily translated if it's a string, because there's all things about casing and C# versus a database engine and so on. So there's no easy translation of contains with strings, and that's why it's bulking. So in addition to not being able to translate these queries with contains with strings, which is something you actually get in with EF Core 8. You could potentially get this runtime error if your database compatibility level is not 130 above when you're adopting EF Core 8. You can easily write a query to find out what your database compatibility level is, but it's definitely something you should consider before adopting EF Core 8. We saw the queries, we understood the reason why, and this was actually one of the most upvoted features in their backlog by the time they started planning EF Core 8, is to get this performance feature fixed. So they did that, and that actually enabled them to add good support for using primitive collections as well. Another feature they added was raw queries for unmapped types. meaning you can actually, let's step back a bit. Before there was always this discussion like, should I use Dapper? I want to write my own SQL, and I can just use Dapper's query, Dapper's query async to get my results. You can actually now do the exact same thing. Until recently, you couldn't do it. You could only do it if the result was a primitive type, like an int or a string or a GUID or whatever, and you just returned that single value from your query. But now you can have any type that your code base knows returned from the code piece at the bottom, which is SQL query. It looks similar. To the query async method in Dapper. So the code at the top, that's how you do it in Dapper, or one of the ways to do it in Dapper, I would say. There's probably more ways. And the code at the bottom is how you would do it in EF Core 8, and how you can do it in EF Core 8. On top of that, you can actually compose queries with SQL query returns an iQueryable. So if you are doing a select statement, or if you are selecting from a view, or if you're selecting from a function that returns a table, you can do that in SQL Server in particular. I don't know so much about other engines. Then you can actually compose a link query with like add where statements or ordering and so on top of the SQL query. Let's do a quick demo of that. So in this sample, we just have some random classes that are not collected. They're not part of our DB context. They're not involved in the DB context. They just happen to be part of the code base. And it's one called blog summary, post blog summary. We'll see blog post. So you can actually use blog post, which is one of those, and it will just return. This is just the one example we saw here. Not so interesting, but let's go down to this one, for example. So F5, F5, 5. So here you can see we actually, this one is probably, let's scroll up a bit here. This one down here. So when it's doing the composition, it's actually including the select statement you write as an inner select, and then it's wrapping that with what is being composed on the outside, as you can see. So we have a nested select, but in this particular case, you could actually write this in link as well. But this is very powerful if you want to add a strongly typed criteria to a view, for example. So if you have a view in the database, or a function that returns a table from your database. So let's stop this. I don't know if you noticed, but some of the data that was seeded in the database here was actually using date only and time only. Are any of you using the date only and time only types? You should. They were actually introduced, sorry, let's go back even more. Date and time were some data types that were introduced in SQL Server 2008. So that's like many years ago. And they were in .NET, they were actually mapped to date time and timestamp, which is not correct. Date only represents a date, and date time, of course, has hours, minutes, and seconds. So that doesn't really represent a date in SQL Server, whereas a date is just the date, the calendar date. And a timestamp can expand more than 24 hours, whereas a time only specifies the time of day, like what hour is it during the day? So again, timestamp was not a good mapping of not a good .NET mapping. And then in .NET 6, which came in 2021 approximately, the two new types were actually introduced called date only and type only, which represent these values one-to-one. But still, support was not added in the .NET driver or in EF Core. It was added later. And with EF Core 8, support for that is built in. So why is that important? Well, if you are storing data in your database in date-time columns that actually only represent dates, you are wasting about 50% disk space, bandwidth, and memory because you're filling it with just zeros. Whereas the storage of the date column is optimized and about half the size of a date-time column. So my call to action to you is to go back and reconsider, well, I should actually convert these date-time columns to date because I will save about 50% in storage, bandwidth, and now that you can use them natively in EF Core. So performance is a feature. We've seen that already. It was one of the highest voted things for the team. I'm just going to go through some of the other things that they did recently. So they did a lot of query performance work in EF Core 6. There's a really, really nice and very long white paper on the EF Core documentation side regarding performance and things you should consider when you want to make the most of Entity Framework Core. And Save Changes has had very important performance increases in EF Core 7. Let's see if there's time for a demo. And then this contains performance improvements in EF Core 8 that I just showed you. Performance is a feature. Can we just do the demo? So what the team did for EF Core, I think it was actually 7, not 8, but it's not so important, was that they figured out that we have done a lot of work for query. Let's now visit when we're doing updates, inserts, and deletes. Can we do that faster? And yes, they could. It turned out that save changes is always in a transaction. And when you do a transaction with the database driver, it issues a begin transaction statement over the network, and then it issues the actual SQL statement to change the data, and then it issues an end transaction statement. So that's 3 round trips across the wire. It doesn't matter so much if your database server and your application is on a gigabit network on premises, but if you are doing cloud solutions and there is some latency between your application service, which could be running in a container or a Microsoft App Service, for example, and your database server, which is somewhere else, definitely over the wire somewhere, potentially slower, then the number of database round trips mattered a lot. And they measured about a 40% performance improvement. And what do you need to do to gain this performance improvement? Nothing. You just need to update to the latest version of EF Core. Let's have a look at what they did. So, dev 10. So let's see here. So I'm now, this feature doesn't work for tables with triggers. So I have a table with a trigger, and I told EF Core that this table has a trigger, so it will treat this table as a table that doesn't support this new way of saving data. So we can see here it's executing a begin transaction, the actual update statement, or sorry, insert statement, and then the end transaction, which means 3 round trips over the network. And the same for let's just step to this as well. F10. And the same for this. And in this insert statement, in doing a lot of complicated stuff, it's declaring a table variable and doing a merge statement. It's pretty hard to read this SQL statement. And actually it turned out that creating this table variable was also a performance impact, because that actually creates an object inside the database engine every time you do an insert of multiple rows. And again, also 3 round trips over the network. So it's not only the common case of just adding a single row, it's actually also the case of adding multiple rows if certain conditions are in place. So this was a single row with the new approach, no begin transaction. Set implicit transactions off is set just to make sure that you haven't configured implicit transactions to be on anywhere else on your database options, for example. So it's explicitly setting implicit transactions to off and then executing the insert statement. And the same for the multiple update statements here. Let's see. See a very simple statement, just insert into values, and that's because it's also a little bit magic, because they're actually using a sequence, which means that the values that are inserted as identities, as keys, are actually available on the client side before this insert statement is executed. But of course, you can imagine that this has a huge impact on insert and save changes performance. So now we have 2 minutes. Yeah. In my abstract, I was very optimistic and promised I would be able to show you Woodstar, but it will be slideware, I'm sorry. Woodstar is a new .NET driver for SQL Server. So the current one is Microsoft Data SQL Client, which is the successor of System Data SQL Client, which was part of .NET Framework. Microsoft Data SQL Client is also runs on .NET Framework, but it also runs on .NET Core. But it's an old code base. It's basically dates back to when .NET was invented in 2001. If you look at it, your eyes will definitely bleed. So the EF Core team felt that there was a need for a new .NET driver, which was based on like .NET 6 or .NET 8, and using the newest technologies with no memory allocations, using spans and so on, because it's basically about getting stuff over the wire and getting it to the client as fast as possible. They promised they would do something, and the community could contribute when I wrote my abstracts, but yeah. So it goes. You can read a little bit about it on the link down there. I also have a collection of links at the end that I'm sharing with you. But I think it's definitely, I'm very excited about it, but I'm not really sure exactly what I'm excited about yet. But I'm sure it will have a huge impact on performance. But there's a long way to go. And it's difficult to kind of scope this new thing, because the current driver has to support every new feature that the server team comes up with, whereas this will be more focused on raw data access, certainly initially, possibly only in cloud scenarios. Again, when I wrote these abstracts, I was a bit optimistic, and the team promised that they would provide a Visual Studio tool I'm the author of a tool in Visual Studio called EF Core Power Tools, but the team felt that there was something missing, like something that was built into the, so if you started a new project or add item, there was nothing there if you were working with EF Core, and so the team felt they should be doing something. I recommend that you use my tool, of course, because it's much, much better. And would always be much better. The team agrees, but they wanted to do this. One of the team members was kind enough to share what he had done so far with me, so I can show you some screenshots. It will be like you can add new item. There will probably be other places where you can start up, but you can add new item, and then there will be an entity framework core model that you can add. You can choose whether you just want to use code first from database or an empty code first model which just generate a DB context for you. You specify basically the parameters of the command line tooling that is already there, like the connection string, the name of the provider, the few options. These are the 3 options that are available in the built-in command line tooling. That's it. I have hundreds of options in my tooling, of course. And then you can pick what objects you want to include in your DB context, and that's basically it. I'm 1 minute over, I'm sorry. Next steps, go and try the RC, and even better actually, because the RC is quite old now, wait until the 14th of November and give it a try. I'm sure you will think it's a great release from the team and the community. I was fortunate enough to contribute a couple of new features here as well. November 14th, watch.NET Conf. There will be multiple sessions covering EF Core at .NET Conf. I will be giving one, and the team will be giving one, but also a lot of other sessions will pull EF Core into their talks. Q&A, well, it will be outside. I will be available, and you can also catch me on Twitter or on GitHub or whatever you want to. In this link here, there's like a little gist with some calls to action and also contact information for me in my GitHub profile. So of course, feel free to reach out. And I'm sorry I went over time.